Harmonize with me and hold me tight all through the night. You're shining bright, I'm your oyster, baby, you're my pearl.
Billy, I'd like to start with an instrumental song.
Oh, I can't wait.
Join in if you're feeling it.
I do.
Now, for any of our listeners or watchers who were wondering what that was the instrumental stylings of the Antiques Roadshow.
Wonderful.
One of the great BBC institutions, I think.
Although at one point, I think it did go into the theme tune from Jurassic Park.
Yeah, I think there was some Jurassic Park. And what was that film, that TV show about the horse, not Black Beauty, Mr. Ed. There was another one about a horse kind of in Cornwall. Felt like that as well. Have you got anything in your house that if the Antiques Roadshow came through your town, you'd say, let's take that?
My gran.
She was 100, wasn't she?
Yeah, and she loved Antique Roadshow. Antique Roadshow, Dom. For anyone who hasn't watched it, if you could tell our listeners what that show is or was. Is it still on?
Still on.
Tell people what it is.
It's an institution. I'd love to. The Antiques Roadshow, it's a road show, so it moves through certain cities, comes to your city, and if you've got possibly an heirloom,
something that's old, that's been in the family for a while,
and what you think might be valuable, but you've never really had the full valuation of it, take it to the Antiques Roadshow, and they have people, different experts. He's an expert in silver. She's an expert in painting. He's an expert in textiles. You line up, they give you a valuation, a little history of the thing, and they tell you how much it's worth. And you always watch the Antiques Roadshow hoping that someone brings in something that they found in a car boot sale for £6, and it's a $400,000 painting.
Yeah, or it's a set of 6 egg cups. Oh, this was owned by Anne Boleyn.
Right.
This is absolutely priceless.
Yeah, it very rarely happens, but there has been. I'm sure you can Google search or YouTube search the top 10 most amazing moments in the Antiques Roadshow where something's incredibly valuable.
I'll tell you the number 1 right now.
Go on.
A guy went, and you can Google this.
I'd love to.
He went, and I can't remember what he had. I think it was a painting.
Good story.
But anyway, they did the valuation, and it was okay. Oh, it's worth a couple of £100. But anyway, they got chatting to the guy, and he's maybe about late 70s, early 80s, older guy. He was in the war and all that.
Oh God.
So he says to him, I tell you what, I've not been sick a day in my life. And they said,
oh no.
And they said, that's amazing. What is your health routine? What do you do? He says, I take 1 clove.
What?
He says, I take 1 clove. He says, this old guy, he says, I'm not looking at you.
No, don't.
He says, I take 1 clove of garlic every morning and I shove it on my bum.
Really?
Yeah. This old guy.
Wow.
And he says, never been sick a day in my life. And they said, you do what? I take 1 clove of garlic and I put it up my bum.
Wow.
And there's no end to that story. There's
Really?
no joke or anything.
Wow.
This guy swore by it, Dom.
We should maybe try it.
Well, you can if you want.
I mean, a bulb of garlic's probably got a month's worth of clothes in there.
It's not,
right?
so it's not expensive.
Does it go up and then the first thing that falls out when he has a little jobby is a little clove of garlic?
I don't really know the ins and outs of it, but that episode, more than egg cups with Anne Boleyn, that is stuck in my mind.
I bet the host was quite kind of confused by the side swerve comment. You look very well. It's like, yeah, I go for walks every day. I've got a dog. I avoid alcohol. No, I shove garlic up my arse. Oh, great. Okay, moving on. Here's a picture of a boat.
I found in the attic.
That's great.
So there you go, John.
Well, that's the Antiques Roadshow. Fantastic. If you guys have any stories about antiques, let us know. But today, Billy, we're very excited because we've got a guest, haven't we?
We have an amazing guest today, Tom. Like, unbelievable. I mean, I have to give John a round of applause, our producer.
Hold on, Johnny boy.
You know, organising this, because as you know, occasionally on the podcast, we go off on tangents, and that will often bring us to physics and questions of the known universe, and sometimes string theory.
Yeah.
Who would you get if you wanted to talk about physics and string theory?
Well, I would say, kind of string theory daft. So you'd be a great guest on a podcast just to kind of give people a general overview of quantum physics. But if you're looking for an expert, there is one guy out there that's written a bunch of books and is very well respected, right?
Professor Briane Greene.
Wow. He's probably your number one guest, and we've got him.
And here it comes. I'm quitting after this. All right. Here's a little intro into Briane Greene. Briane Greene is a professor of physics and mathematics, is renowned for his groundbreaking discoveries in superstring theory, including the co-discovery of mirror symmetry and of spatial topology change. He is known to the public through his books, The Elegant Universe, of course, The Fabric of the Cosmos, lovely, and The Hidden Reality, which have collectively spent 65 weeks on the New York Times bestsellers list and sold more than 2 million copies worldwide.
Incredible. The Washington Post called him the single best explainer of obtuse concepts in the world today. Professor Greene hosted 2 Peabody and Emmy award-winning Nova miniseries based on his books and is a frequent television guest, joining our friend Stephen Colbert. 7 times on his show and playing himself in an episode of The Big Bang Theory, buddy. Let's bring on Briane Greene to talk about all things tiny. Hey, thank you so much for joining us. I will speak on behalf of my colleague, Billy Boyd here, who told me when we started this podcast that his number one guest on the show would be you, sir. So we're very excited.
Is that right?
Absolutely.
Wow.
He's obsessed with all things string theory. So, Billy, over to you.
Hello, Mr. Briane Greene. How lovely
How
to
are you?
meet you. Thank you for coming
to
on
meet
this show. Really lovely.
My pleasure.
Thank you. Have we started recording? Are we ready to go? Oh, we're good.
It's actually happening.
This is actually happening in the universe.
Or is it?
Or is it,
In this
Mr.
universe.
Briane?
Yeah.
Yes, exactly. And probably many others. In fact, why don't we start with that? We shall start with universes, and is there only one? Is that a good place to start, or is that too...
Well, why not?
We'll just dive right in.
Why
if
not?
you've got Professor Briane Greene, why wouldn't we dive right in?
We only have a finite amount of time with Professor Briane Greene.
Or do we?
Yeah.
No,
You've heard all these jokes
Right,
before,
come on.
I'm sure. Okay.
So, can we call you Brian or Professor
Yeah,
or
please.
Mr. Greene? Brian,
No,
okay.
Brian's great. Brian's
Right.
great. Thank you.
So, Brian, let's start with that. We'll do everything probably from your sort of point of view. So we'll be asking lots of questions on probably what you think. So do you think there is more than one universe, or is everything that we see what we see?
I honestly don't know the answer to that. And I'm not embarrassed to say that because there's nobody on the planet who knows the answer to that question. What I can say is that there are reasons for taking the possibility of other universes, as crazy as the idea sounds, there are reasons for taking it seriously. When we pursue the mathematical understanding of a variety of theories, quantum mechanics being one of them, the attempt to understand the so-called unified theory that we do with string theory, trying to understand the Big Bang that started things off in our universe. All of these approaches wind up suggesting the possibility that our universe might not be the whole thing, that there might be these other universes.
Incredible.
And so we're willing to take the idea seriously, pursue it, but we don't believe it until we've got evidence, and we certainly don't have evidence for it yet.
And do you think that's the reason that we find it difficult to think of other universes, do you think that's because of the human mind thinking of size? And we just see the universe and think, well, that is so huge. Like people like yourself have told us how big the universe is, how far galaxies are apart, how many billions of galaxies there are. So how can there be more? But I think I read in one of your books, I think it was one of your books, I'm sorry if it wasn't, there was an analogy of if it was a bubble in a bathtub.
Yeah, that was my book, I think.
Right. So the idea that if you thought of everything in the universe and then thought of all of that was a bubble in a bathtub, then all the other bubbles would be the other universes.
Right.
Then that would be a sort of analogy of that thinking. Is that correct?
It is, but it really speaks exactly to the intuition that your question started with.
Yeah.
When you think of a bubble in a bubble bath, you think of it as having, a finite size.
Yeah.
And that allows for there to be other bubbles outside of it. But when it comes to the actual universe or space, many of us just imagine it goes on forever.
Yeah.
It doesn't ever stop. And then you've got that puzzle on your hands. Well, if space in our universe goes on forever, there's no room, it would seem, for other universes.
Right.
And I understand that intuition well. It's based upon experience. And experience is what allowed us to survive through the eons and allowed us to navigate the everyday world and find the next meal and find shelter and so forth. But we've learned that mathematics is a better guide to the nature of the world than our senses and our intuition. And mathematically, we understand well how, even if space in our universe goes on forever, there still is room for other universes and other realms. The space in our universe need not exhaust all of the possible places that another universe could reside. And so we have no problem mathematically understanding how our universe could go on forever, and yet there still could be room for other universes, even though the human mind has a hard time grasping that idea.
I think that's great, but I think that's the thing, isn't it? That, as you say, our mind is made to do something. And if you understand math, then you can understand the universe in another way. But I think what you do beautifully with your books and with your TV shows is that you can take those ideas out of the world of math and try to explain it in a different way that someone who doesn't have that mathematical history can sort of try to get their head around it. And I think that is really impressive what you're doing with that. So thank you very much.
Yeah.
No, thank you. And that is the point. The hope is, look, these ideas are so mind-bending that it's tragic that many people who would be enormously excited to learn of these things feel cut off from it because they don't have a graduate degree in physics or a graduate degree in mathematics. So the point of my books and many other books too is to translate from the esoteric language that we use when we're doing the scientific research, advanced mathematics, and translate it to just the ideas that anybody who's willing to put in some effort can grasp. And it's a wonderful thing when even kids, I sometimes get letters. It's always surprised me from the first time I got one, 5-year-olds, 6-year-olds who've read a book of mine or watched a television show and have questions, and they either write it themselves or get their parents to write a question. And you see a young mind expanding by virtue of encountering these possibilities of other universes or the weirdness of space and time and relativity or the weirdness of quantum mechanics. So these ideas need to be more widely discussed and understood because it's our heritage as members of the single species that's been able to figure this stuff out.
Billy and I think, take a huge amount of comfort and satisfaction in being aware of just how small we are as individuals on this planet, and as well as starting to include the size of our solar system and one of the things that I loved in, as Billy was saying earlier on, your ability to make things much more easier to digest in your recent book was trying to make sense of the stars that we see in the sky, and that everything seems so clustered together because we're not able to see distance. And Brian said, if you imagine that our planet is the size of a grain of sugar,
Yeah.
and it's based in New York, the closest star is in Connecticut.
Oh, wow. Yeah.
I just loved your
Yeah.
ability there to be able to make a visual picture for people not able to understand what they're actually seeing in the night sky. That was an amazing thing to read.
Yeah, I mean, the night sky is wondrous but misleading, as you're noting, because when we look at the stars in the night sky, our eyes, as you emphasize, are unable to really discern the distances to the stars. They all more or less look like they're the same distance up there on the cosmic sphere that surrounds us.
Yeah.
It almost looks crowded up there on a nice, clear night. But the reality is all those stars are at vastly different distances. Most are very far away. And so it only looks crowded because the eye tends to compress them all at the same separation. But there are a great range of separations. And indeed, the closest one is far away, 4 light years away. Light years about 6 trillion miles. So we're talking about, 25 trillion miles away to the nearest star.
Wow.
Besides the sun, of course. The sun is the nearest of all, but beyond the sun.
So, well, can we bring it back a little bit, Brian? I mean, I'm sure you've gone through this quite a bit in some of these interviews, but could we ask you as a 8, 9, 10-year-old boy, what were the moments for you where you read a piece of scientific information that made you go down this particular path?
Yeah, for me, it didn't start with science per se. It actually started with mathematics. I was one of those nerdy math kids who just loved to solve problems and learn areas of mathematics. My dad didn't go to college or anything. He was a high school dropout, but he knew enough of the basics of mathematics to get me going. And he got me going at a young age, multiplying big numbers against other big numbers. That's how I'd spend a Saturday or Sunday, unlike others who might go out and do other things. And when I then learned a little bit later on that the math wasn't just a game, but that some people use the math to understand the world. And when I began to understand how that went, I was just utterly thrilling to recognize that you could sit with a pencil and a piece of paper and determine things about the outside world. You could determine, the distances to stars and the qualities of the shapes of things that you see in the environment. A hanging thread, you could calculate its shape, just sitting down and thinking. And that to me was just spectacular.
Amazing.
So that's, and do you think, thinking about that and trying to get kids into math and stuff, it makes me think the book, Icarus and the Edge of Time that you did, that I was lucky enough, I did a performance of it with the Scottish National Orchestra.
That's fantastic.
With the Philip
was I
Glass.
at that performance, or I?
No, you weren't there. They were doing a thing on minimalist composers, and they'd taken that piece, and I didn't know the piece at the time. And for anyone who doesn't know it, you must go out and watch the movie. There's a movie of it. It's brilliant. And it was Brian and Philip Glass who did this piece together.
And Alan Al, you two artists in your neck of the woods.
Yeah, that's right. And the idea was the sort of Icarus story, wasn't it? And what I loved about it was Icarus doesn't die, which I think is a good thing to teach kids, is like just trying something. In the original Icarus, he makes wings, flies too close to the sun, and and he's dead. Well, this one, which maybe you could explain it to us, Brian, but it gives you a sort of introduction to relativity.
That's the point. In fact, when I first learned about the classic Greek myth of Icarus, it really troubled me that the young boy died.
Really?
Because he was doing the bold thing. He was exploring,
being curious. Yeah.
He was curiosity. Yeah, he was going into the unknown, and to die for that always struck me as the wrong lesson to learn. You know, and so that's what really inspired me to write this futuristic version where the boy, again, against his father's warning, goes where he's not supposed to go. He makes a ship and flies to the edge of a black hole instead of near the sun. And you're right. In this version, he does not die, but rather, when you're near a black hole, the real physics that Einstein taught us is that time slows down. So he spends what he thinks is an hour near the black hole on this joyride in a ship. But the rest of the outside world, time is going much more quickly than it is for him. So when he comes back, it's not just a few hours later, it's 10,000 years into the future. So when he returns from this exploration, he doesn't die, but he does have to acclimate to a completely new reality that emerges from his own bold exploration. And that to me is what science is all about. Right? You don't die, but rather you do have to change your views of the world when you explore and you discover new things. And that's a good thing. That's what science is about.
And you're a huge fan of Einstein, right?
Yeah, you could say I'm an Einstein fanboy at some deep level.
And he wasn't afraid to admit that he changed his mind on a few things. So I think that's the great thing about science is this is our knowledge and belief at the moment. But when someone finds something else, they say, well, that does prove that it's something else or it's slightly different. And I think that's a great lesson as well. And my son who's 15 now, came to see that show when he was about 4 or 5, and it totally blew him away, that idea. And the amount of questions he had after that. So maybe that's a good thing to talk about, relativity and time and black holes, because I find that incredible. So that science is real, what you put in that story, that if you get close enough to a black hole, time slows down.
How do we know that? How do we know time slows down? Because we haven't been close to a black hole, have we?
It's a good question. And the answer is, time doesn't only slow down when you're near a black hole. Time slows down when you're near any source of gravity. Now, a black hole makes it more dramatic because the gravity is so powerful that time slows down a lot. But even on the surface of the Earth, you can compare a clock that's, say, at the top of a tall building like the Empire State Building with a clock that's on the ground. And the clock that's on the ground being closer to the Earth, closer to Earth's gravity, time will tick off more slowly on that clock compared to the one that's at the top of the building. And this has been measured. This is not conjectural. And the amount of time difference between the two clocks is exactly in keeping with what Einstein's mathematics predicts. So we then just extrapolate from those and other observations where time truly slows down in a gravitational field. You just extrapolate that to a more powerful gravitational field, and you conclude that time slows down even more in a very specific way dictated by Einstein's math.
That's probably why rich people like to live in penthouses. They live a little bit longer. It actually
be the reverse, right? Because rich people in some sense, are aging more quickly.
So it's the opposite.
It'll be like hobbits, live under the ground.
Realize it.
So do we know where the closest black hole to our planet is?
We don't. We know for sure that there's a black hole in the center of the Milky Way galaxy, but that's, many tens of thousands of light years away. So it's very distant. But could there be a black hole nearby that we don't yet know about? Not impossible, for sure.
Right.
That's right. That's good. That's a good. I like these basic questions of black holes and like planets. It wasn't long ago when we didn't know there was other planets, right? Yeah. And now we're saying there definitely is.
Oh yeah. No, there's incontrovertible evidence now for exoplanets, planets that are outside of our solar system, and planets seem to be commonplace. So a great majority of stars seem to have planetary systems, much like the sun has us and the other planets of our solar system. And just statistical analysis suggests that many of those planets would have conditions that are not that dissimilar to conditions here on Earth. And that's what leads some to the conclusion that maybe life out there is commonplace. That's not proven by any means. Life on planet Earth arose from a whole variety of conditions and perhaps unlikely conjunctions of qualities. So maybe life is rare, but the conditions on Earth seem not to be that special.
Your most recent book was called To the End of Time, is that right?
Yeah.
Talks about the death of the sun, which is absolutely terrifying and fascinating. And you had
the death of everything else too.
Right. You had mentioned that seeing the death of the sun would be a phenomenal thing, but obviously you wouldn't want to be there. That particular book you seem to be making a very strong point throughout that whole book that everything is finite, everything dies, which, again, I think Billy and I take a huge amount of comfort in that. I think some people probably don't. But sometimes if I get into these conversations with people about that particular subject, we'll have, and I'm sure you've had this conversation too, Brian, that they will say, well, we are made of energy. Energy doesn't die. When we die, where does that energy go? I make the comment that I have some understanding that as we lose our core temperature, some of that energy kind of dissipates through us losing the heat in our body. Is that quantifiable down to a zero, or is there a certain number in terms of the energy that we have inside us that could potentially be passing into something else?
Well, I would agree with those who note that, yes, we are energy. And indeed, we do believe, at least so-called locally, in the conservation of energy, that energy really doesn't just disappear from the universe. So the energy that makes us up, I would say all of it winds up dissipating into the environment once we dissolve into our constituent parts after we die and we decay. But the thing that distinguishes us is not that we have energy. Almost everything has energy, right? My laptop has energy. My coffee cup has energy. What distinguishes us is that our energy is highly organized. And it's the orderly nature of our energy, the orderly nature of how the particles that carry that energy are pieced together into the atoms and into the molecules that make up the cells, that make up the organs and so forth in our bodies. And order and organization, that is not conserved. Order and organization can go away. This is the so-called second law of thermodynamics, that entropy or disorder is typically always on the rise. So it's not that our energy is lost, but our order is lost when we die.
Interesting.
And I think that's the point you're making in the new book, isn't it? That everything is trying to get that entropy. Everything is slowly disorganizing itself. So at some point, the universe will just be universally covered in stuff. And stuff won't be tables and chairs and people.
Right.
It'll just be stuff.
Right.
It would just be the particles,
Yeah.
the fundamental particles. And so we're living through a very special epoch in cosmological history, right? We live during the epoch when organized, orderly structures can persist for a little while. But if you look at the grand cosmological timeline from the beginning until whatever we can call the end, that window when orderly structures can exist is very tiny on cosmological scales. For the vast majority of the cosmos, things will have disintegrated into their particulate ingredients, electrons and other similar particles that will just be wafting through space. And for nearly an eternity, that's what the universe will be. No tables, no chairs, no people, no consciousness, no life, just particles wafting through the darkness.
You had mentioned that in the death of the sun, obviously the drastic cooling of the planet, the oceans would freeze over. But you left a line in that particular statement that there might be a big possibility of life in the frozen oceans deep down there, because obviously a lot of life can live there. Potentially, as our solar system struggles with the death of the sun, there could be a little frozen element of life in the very deep oceans. That again made me think, oh, so much hope for what could happen next, you know?
So it is sort of hopeful. I agree, because, you know, as it turns out, there's a lot of radioactive decay that happens deep inside the Earth that can be the source of energy. You know, as the Earth is tugged on perhaps by other planets and the sun, there can be friction in the core of the sun that generates heat that might sustain life. But that hope is itself very short-lived on the time scales that we're talking about. You wait long enough and all of those sources of energy will have dissipated too. So yeah, it does extend the domain when life in principle might be able to survive, say deep down into the oceans. But you wait long enough and it all goes away. It all ultimately dies.
So let's go right back to the start then, right back to the Big Bang, because there's a part of the Big Bang that annoys me, and maybe you can help me out here, Brian. Like, obviously, it's to get our head around everything in the universe was at one point a tiny nugget of everything, and then it explodes. Fair enough. Okay, we'll put our head around that. But this moment of inflation, or is that the right word? Because Einstein said, right, correct me whenever I'm wrong, that nothing can go faster than the speed of light. But in this Big Bang theory, there was a time when everything went faster than the speed of light. How can that be?
Well, it can be because when you look more closely at what Einstein actually said, as opposed to sort of a quick summary of what he said, what he actually showed is that nothing can move through space faster than the speed of light. Now, you might think that's just sort of a technical detail. Why does it matter? But it matters because in the early universe, when everything was expanding, everything was rushing away from everything else, it was space itself that was swelling at a speed faster than the speed of light. Nothing was actually moving through space faster than the speed of light. It was just the substrate. Space itself was stretching faster than the speed of light, and nothing in Einstein's depiction constrains the rate at which space itself swells. It only constrains the rate at which, a baseball or an object goes through space.
Right.
And that's not the relevant thing when you're talking about the expansion of space itself.
So basically, we're saying the Big Bang is basically space being created. And it's being created in an expansion and a sort of inflation sort of way. And then once that's done, then everything inside it can move, but everything in there can't move faster than... You've explained it to me, Brian. Thank you. Because I've never got that, and now I've got that.
Well, we can take that one off the list.
I'll take that one off.
Billy
but
and
you know what?
Even
Even today, there are examples of that phenomenon, because distant galaxies, if they're far enough away, they move away from us faster than the speed of light, but not because they've got like some rocket engine that's causing them to move through space. Again, the swelling of space continues. Space is still expanding, and as it swells, it's driving galaxies. If they're far enough apart, they're driving them away from each other at a speed that's faster than the speed of light.
I didn't know that.
I didn't know that either. Can I ask you a theoretical question, Brian? But you're the right person to ask theoretical questions too, since that is a huge part of, what you do for a living. If you were stood on a planet witnessing the Big Bang with your bare naked eyes, what would you see in front of you? What would that be?
Well, it's slightly hard to address precisely that question, because that planet itself couldn't be there if you're witnessing the Big Bang. It actually emerges from the process. But put that to the side.
Yeah.
Put that to the side.
You could be floating in space, whatever.
Yeah. So
There is no
the universe,
space.
so the universe itself, space itself, would be pretty uniformly filled with an energy field. Now, your eyes aren't really attuned to see that energy field, but let's put that to the side as well. Let's say that energy field looks like yellow or hot or orangey.
Yeah.
It would be a uniform glow of that color if you could see this energy field. And as space expanded, that energy would spread out and ultimately the temperature would come down. And so were your eyes sensitive to that, you would notice a change in, say, the color of the ambient environment. And so for a long time, long on cosmological scales, there wouldn't be anything interesting happening. It'd be a pretty uniform environment whose temperature would be steadily decreasing over time. And ultimately, structures begin to coalesce out of that uniform energy field, giving rise to particles and collections of particles called stars and planets. And then you could be on a planet looking out as we currently are and beholding the result of that whole process.
Ay.
But that is, I know you might not be into this sort of thinking, but that is if you look at the sort of ancient spiritual thinking, that's basically what they say as well, isn't it? That there was energy and then energy became things.
Yeah.
And basically they're saying to be enlightened or whatever, just try and get into that energy again and stop thinking about the things.
And as poetry and as metaphor, I think that's beautiful. And I think that it's wonderful that ancient people and ancient civilizations tried to find a coherent way of thinking about reality and our relationship to that reality. So all that's quite wonderful. The thing to bear in mind, though, is it doesn't go beyond the poetry or the metaphor. The thing that science can do is it takes those ideas, it makes them precise. It puts mathematics behind it, allowing us to make predictions that we can go out and look at the night sky and measure to try to confirm or deny these predictions, refute them. And that's not what any of these ancient traditions are able to do. So sort of as a qualitative, poetic, metaphorical description of reality, I think these are beautiful descriptions.
But
science does distinguish itself, though.
Yeah, no, absolutely. But I do think quite strange that these ancient had this thought of this, that everything is energy, and it's just quite, it's quite impressive that they have these images for some reason.
Yeah, profound. But I'm guessing that maybe if these ancient communities were able to access some of the things that we know of now, like meditation or elements of rhythmic breathing or plant medicine, things like that, you can get to those places.
Those sort of thoughts,
right? Those kind of euphoric thoughts. Like Brian said, it doesn't have a massive amount of evidence and theory behind it.
But the other thing to bear in mind is that language changes over time. And so what we mean by words like matter and energy and so forth has a different connotation than perhaps what those words may have meant in an ancient tradition and ancient text. And I think it's fine to draw a dictionary, an association between the words as we mean them today and similar concepts that find their way into ancient traditions. That's a great thing to do. But again, it is one of analogy and metaphor and poetry as opposed to rigorous description of the world.
Sure. Yeah, absolutely.
One of the toughest conversations that I get involved in. My father was a science teacher for all of his life, and my brother is a science teacher, and I come from a family that is deeply entrenched in science. And I'm sure you have this too, Brian, is when people say, well, X, Y, and Z is just a theory. And you say, well, no, that's scientific theory, which is completely different from the theory of the moon being made of jam. Scientific theory is scientific fact, but they hang themselves on this idea of, well, that's a theory in the same way that, my legs are made of rubber, and trying to get people over that issue that they have. It's a shame. I understand why the word is stuck, but it's a shame that the word theory means something different when you're talking about science, as opposed to the dictionary definition of theory that we often bandy around willy-nilly.
But part of the problem there is that I think this is a self-inflicted wound to some extent, because scientists themselves don't always use the word theory in a consistent manner. I mean, the two words that really should be used are hypothesis and theory. And a hypothesis, I think, is closer to the colloquial meaning of theory. You just throw out some idea that maybe this is the explanation for why this or that happened in the world. That's a hypothesis.
Right.
When the hypothesis is tested and subject to observation and experiment, and if it comes through that rigorous testing, then it deserves to be called a theory. Now, the problem is I work on something called superstring theory. Superstring theory really should be called superstring hypothesis. We've been developing these ideas. They're mathematics, but they have not yet been tested. They have not yet been subject to that confrontation with data. And so we scientists shouldn't call it a theory. We should call it a hypothesis, but for whatever historic reasons, we call it superstring theory and thereby muddy the language, muddy the water.
I don't even know what it's called, but when there was two, maybe it's electrons or protons, who were together are then apart, and something happens to one, it'll happen to the other. Again, we're back onto the speed of light sort of thing. But no matter how far apart they are, those will affect each other almost instantaneously.
Yeah. No, this is what you're referring to is called quantum entanglement.
Yes, exactly.
Yeah, and it was discovered in the early days of quantum mechanics by Erwin Schrödinger, one of the pioneers of the subject. But it was really Albert Einstein who I think was most troubled by this quality of quantum mechanics, where, as you say, you can have two particles, they interact for some period of time, and then you separate them. And regardless of how far you separate them, whatever you do to one particle somehow influences the other instantaneously. Now you'd say, oh my God, what about, again, nothing going faster than the speed of light? And the math and the theory gets by, you might say, by the skin of its teeth, because as it turns out, the interaction is more a correlation in behaviors. There's no way to send information, a signal from one particle to the entangled member of the pair. And it turns out that's enough to make this technically compatible with Einstein's declaration of nothing going faster than the speed of light. But Einstein was not happy with this idea. He thought it would be the downfall of quantum mechanics. And he wasn't a great fan of quantum mechanics and liked that it had a potential downfall. So he put this forward in a paper as a downfall of quantum mechanics. But it turned out it's not a bug. It's not a problem of quantum mechanics. It's a wondrous feature of quantum mechanics that now has been experimentally confirmed. So what Einstein thought would be the death knell of quantum mechanics is now the most spectacular quality of the theory, that distant objects can behave as though they are right next to each other.
Wow. He called it something, didn't he? He had a
spooky action.
Spooky action, that's right. Because, you know, they could be so far apart, but if you turn one up, the other one will turn.
Instantaneous.
And this brings us on to, I think a lot of people, a lot of listeners might be interested in, all right, this is all very good. And, you know, we can think about these things. But what does it actually do for life on this planet just now? And am I right in saying that is quantum computers use that theory now? But does anyone actually know what's going on? Why that happens?
Yeah. And so I'm happy to answer the question. I'll just preface it by saying I'm a great fan of convincing people that looking for value in science by how it affects everyday life may not be the right measure.
I'm 100% with you, Brian. I think the whole reason we're on the earth is just to think about stuff and just, you know, try and work it out and have fun. But I know a lot of people, that's always the thing with NASA, and it's always the thing. What does it do? You know, what do we get from it?
But nevertheless, I mean, quantum entanglement does do a lot for us. And as you note, it is an essential part of this new approach to computers, this approach called quantum computers, which as they now are in an early stage of development, but the supposition and belief, anticipation is that one day quantum computers will be commonplace and they will be potentially far more powerful, far faster than any computer that we've had so far. And at the core of that is this quantum process called quantum entanglement. But something a little bit more mind-blowing is that quantum entanglement allows us to carry out teleportation.
Now
Right?
we're talking.
Anybody, teleportation is this weird idea where you take an object over here and somehow you make it appear over there. Like we're all familiar with it from Star Trek and so forth. Nobody can do teleportation of human beings, so I don't want to be misinterpreted here. But there are scientists today who teleport individual particles from one location to another. In fact, there's a physicist named Anton Zeilinger. You should have him on the show sometime. He teleports particles from Tenerife to La Palma, two of the Canary Islands, 90 miles apart. And he uses this quantum entanglement to be the backbone of how he's able to teleport these particles. So the next question, of course, is, well, can we go beyond teleporting single particles? When can we do it for macroscopic objects and people?
Right.
I have no idea. And I can't imagine that the protocol that's being used for particles can be scaled up to work for the huge number of particles in the human body. But I'm one of those people who will never say never. I don't know. Maybe one day we'll be clever enough and be able to do that. But I tell you, the first teleporter that's developed, if it happens in our lifetime, I will not be the first person that steps in. I can assure you of that, man. Somebody else is going to try that out. No, you got to
watch. Especially if there's a fly in there with you.
If there's a fly in there, you're in real trouble. I saw a documentary about that once. It wasn't great.
Billy and Dom eat the world.
Brian, we could talk to you all day, and you're an absolutely fascinating human being. We are running out of time, and we do a regular feature on this show called Billy and Dom Eat the World. You've recommended a fantastic ice cream to us that John is going to bring in. Whilst we eat the world, I'm sure we still have some questions for you, but we are on a ticking clock here, Billy. So if you've got burning questions for Professor Greene,
there is many.
I will get them out now.
There is many, but we will go on to ice cream for a bit. But
you're gonna have what? You're gonna have some vegan ice cream?
We're gonna eat some Van Leeuwen. What is that? Right? How do we say it? Van Leeuwen.
I don't even know how it's pronounced. I know what it looks like in the logo and so forth. But it's dairy free. Dairy-free ice cream.
Now, you're a dairy-free string theorist. Is that correct?
I'm a dairy-free. I'm more than that. I'm animal-free. I don't eat any products of animal origin whatsoever.
Good for you. How long have you been vegan at that?
Oh, man, that's going on 30 years now.
Wow.
Okay.
Yeah.
Was that just something that you did to try it out and it stuck? Or?
No, I was a vegetarian since I was 9 because I ate my mom's spare ribs and they were so vile, and I realized that they were ribs, and that just completely grossed me out. So I stopped eating meat. But about 30 years ago, I then went to an animal sanctuary in upstate New York and learned about the dairy industry and how they just destroy these animals. They turn them into like milk producing factories. It's really horrible. And after learning about that, I just couldn't go back. That was it.
Well, good for you, man.
I mean, it's amazing, but it's like putting the two things together is quite strange, because you're saying everything's made of quarks. So, if a quark is, you know what I mean? There's a kind of strange sort of disposition there.
Agree.
But I love it. But I love that you're worried about living things and consciousness and good.
But that's the point. That there is a serious point in there, which is you're right. Some people do say to me, "Hey, if it's all made of strings, what do you care whether the strings are vibrating this way or that? Just you're eating strings or quarks or so forth." And my answer is, we look at the world and we analyze it with different levels of explanation. So at the particle level, it's all just particles, quarks, and so forth. But I do care about how those particles are put together. I do place value on life and consciousness, even though it's all just particles. That organization matters to me, and I don't want to eat that organization.
Yeah, no, you're absolutely right. Of course.
Good for you, Brian. Now, as I said, could you bring in a couple of spoons, Johnny boy? Here,
we just use our tongues.
Brian,
what flavor do you have?
We have a honeycomb flavor and a Sicilian pistachio. I'm going to hold on to the pistachio for a second, Billy.
I know this pistachio one. I don't know the other
goodness.
one.
Now, as I said, Brian, we got both of them here. Here, Bill.
Oh, they're on a plate.
These are just to show our wonderful audience at home. So here we go. Here's the ice cream. We'll show it up in a second. Brian, in the finite amount of time that we have, and in the hopes that we can continue to blow our audience's minds and turn them onto your books and your life's work, are there things where if you have 2 or 3 minutes with someone at an airport or someone you're signing an autograph with that says, please blow my mind, tell me something that's going to keep me up at night because I just know this is going to bend Billy's brain. Is there anything that comes to your mind that blows your mind too?
Oh, God, there's so many things. Certainly quantum entanglement comes into it, the weirdness of time and relativity that we discussed. But I guess I would also focus upon my strong belief that we do not have free will. That free will is something that our minds make us buy into. We think that we are the ultimate author of our actions. But when you realize that we are nothing but collections of particles fully governed by the laws of physics, you realize there's no opportunity for us to intercede in the lawful progression of those particles. And everything we think, everything we do, every action we undertake is nothing but our particles moving this way or that under full guidance by the laws of physics. So there's no place for us to end run those laws and intercede and thereby exert the kind of free will that our intuition suggests to us that we have, but we don't.
So let's say I leave this building today and I walk across the street and I get hit by a car. That's been predestined by the physics that I'm limited by.
Here's the beautiful thing. It's not been predestined in the way that I think that you mean, because our world is quantum mechanical, as we were talking about before. And in a quantum universe, our universe, the laws only predict the probabilities for one or another outcome. So there's some probability that you'll be hit by that car, but it's not predetermined in the sense that that outcome is uniquely specified by the equations. The point is, you have many possible outcomes, but you don't pick. You don't choose which one happens. That's part of the unfolding of physical law.
Brilliant. I love it. This is great.
Yeah.
Should we have a bite of ice cream?
Yeah, come on.
Now, this is
How's
dairy.
the ice cream?
Well, we're going to try it right
Hold
now.
on.
This is dairy-free. So do you know, Brian, what makes up the ingredients of this ice cream?
I think it may change from one to the other, but I imagine it's coconut milk, almond milk, potentially soy milk. You have to look in the ingredients there.
Let's have a look.
Okay, I'll tell you, Tom.
Yeah, go on, tell it.
But it's
If we
not
looked
cow's
here-
milk.
What it says here, cream.
What?
That's what it says on the thing. Oh, hang on.
Maybe, you know what? You may not have gotten the vegan version.
Ah,
Oh,
Johnny.
John!
You're offending
does
Professor
come.
Greene here.
It comes in both vegan and non-vegan. Oh, come on, guys.
John,
Oh,
you should be
but
ashamed
John!
of yourself.
I went to the place and they gave
John-
me those
Someone's
two. They
gotta be
recommended
fired
those
on that
for the
one.
No, Brian.
Halloween.
John has let us down a few times over the weeks, but I think this is the worst one he's ever done.
We're eating milk and eggs and cream in front of a strict vegan.
I just read what I'm just trying to look at the ingredients here, and it says eggs, plenty of them.
Oh, come on. Come on,
Yeah.
Johnny boy.
John!
John. Well, we apologize deeply, Brian.
Is yours the
I'm
same?
hurt.
Yeah.
I'm deeply hurt.
I'm hurt too.
So sorry about that.
Just to let you know, almost everything in this ice cream will offend you, Brian. It's made with cream, milk, egg yolks, sugar, pistachios, and salt. So it's
Pistachios
offensive
work.
across the board, but I tell you what, it's tasty.
Brian, we are so
So
sorry.
on your own time, you should try the vegan version.
We will absolutely do
I
that.
promise you that we will do the vegan on another episode, but are we still giving this one marks?
I think we have to give it marks because this is Billy and Dom Eat the World.
We give it marks. We give things marks out of 10. And I think we're going to have to keep doing that, Brian, even though it's not what you suggested.
No, definitely. I mean, how is it? I mean,
Well,
is it good as
it is
non-vegan?
good, but I
ice
would
cream?
like to try the vegan version.
To be
for
honestly,
sure.
it's absolutely delicious.
Fantastic.
Yeah.
We recently were on your friend Stephen Colbert's show, which was fantastic, and he was recently on our show. We watched your appearance in which you had Stephen be part of an experiment where his voice affected a laser. Is that right? Or the way that the laser reacted with a surface.
It's for gravity waves, wasn't it?
Gravity
Yeah,
waves.
it was a demonstration of the kind of process that happens in gravitational waves, where a disturbance in the fabric of space-time affects laser light that we are able to detect. And Stephen, in some sense, played the role of the gravitational wave through his booming voice.
Mm-hmm.
So
He said something like, what did he say? Science is great? Or
I think he just said science.
Science, yeah. That's
But
right.
you've been on his show multiple times. I know that Stephen Colbert is quite a deeply religious, spiritual man. Also, obviously has a very strong connection to the work that you do. Have you and Stephen got into some of these slight contradictions that can occur with a religious, spiritual life and a scientific life? Has he made peace with that?
Yeah, no, I mean, the only conversations that I've really had with Stephen are the on-air conversations.
Uh-huh.
And on air, in the old days, he played sort of a character that would come out with, extreme views and so forth. So that really wasn't him. In the newer show, it is Stephen playing himself. He's deeply interested in the scientific ideas. And I have to tell you, he understands them and he knows them because he always comes up with questions that are spot on that never came up in any of the pre-conversation whatsoever. So he really knows this stuff well. But I'd love to get into that conversation with him, but we never have. The religious versus the scientific, because I know that he has a deep religious orientation.
He's a huge fan of Lord of the Rings, and we do this show because of Lord of the Rings. Have you ever read Lord of the Rings, Brian?
I'm embarrassed to say I have not.
Well,
so
that's
just like you haven't had vegan ice cream. I need to hang my head in shame here because I have not.
That's a good one. That's a good one. I tell the story.
But I have it in my future. I still have it to look forward to.
Well, you still have time, yeah.
It won't be your choice, though, Brian.
Exactly. I can't take the blame for it either. Well, that's another. The issue of blame is a subtle one, so I won't go down that trajectory. But yeah,
I've told this story quite a few times. But my lovely mom was coming to visit me in New Zealand with my dad, and my dad had read Lord of the Rings multiple times. My mom had never read it, and I said to my mom, "You have to read Lord of the Rings because you're going to meet Pippin and Aragorn and Gollum." And she said, "Oh, I don't want to read about magic and wizards and goblins and elves. It's not really my mum's thing." And I said to my mum, "It's not about that. It's about people. It's about characters. It's a human story." So I think some people can get quite put off by the magic and by, the kind of, what some people would dismiss as kind of silliness. But it is one of my favorite reading experiences of all time.
Right.
So I do recommend it.
I will do that.
I probably, to be honest, Brian, to relax, I read your books. I enjoy them more than novels most of the time. I feel like reading about string theory and quantum physics and how the universe may work. I just find that so relaxing and I think your books are wonderful. So thank you very much for that, Brian.
Yeah.
Thank you.
The Elegant Universe was the first one that I read of yours, and it just absolutely blew my mind. And then I read Till the End of Time over the weekend, and phenomenal, just incredible. And like that thing that we've talked about so many times, the feeling of knowing just how small we are is such a comforting feeling,
Yeah.
Yeah.
Well, should we give these some scores so that we can let Professor Greene go? We score this ice cream in 3 categories: flavor, aesthetics, and usefulness.
Usefulness. How
exactly.
useful is the food? So for taste, Dom, I'm going to go first.
Okay, on you go.
It's a 9.8.
Oh, wow, you love it.
There's some of the best ice cream I've ever tasted.
Really? That's great.
It's fantastic. I'm giving it a 9.5. I loved it too, but 9.8, that's lofty.
Mm-hmm.
Aesthetics, I mean, it's ice cream, isn't it? I mean, it's not.
What about the little box it comes
nice
in?
packaging,
Yes,
right?
nice, very simple, very minimalist. I wonder if the vegan one is made from recycled materials and all that kind of stuff. It's a 7.
Yeah,
It's a 7.
it's at 7.2.
And then in terms of usefulness, well, I assure you, Brian, I will definitely buy the vegan version to see how I feel about that, because having a vegan ice cream in your freezer is a great idea. Guilt-free ice cream. But in terms of usefulness, I mean...
It's an ice cream.
Put it in a smoothie.
If you get the non-vegan one, you can really embarrass yourself in front of a professor of physics and mathematics.
Yeah, so that's helpful.
So it's useful that way.
I mean, I don't know how useful it is.
It's not that useful.
It's a 4 for me.
It's a 6.
It's the flavour that it's really...
It's generous, a 6.
Yeah. Well, you could make an ice cream cake from it, I think.
Well,
How useful is the ice cream cake?
Well, exactly.
Brian, we've absolutely loved spending time with you, and I'm sure you hear this all the time. We could talk to you forever. I know Billy's been vibrating for the past couple of weeks knowing that you're coming on the show. Thank you so much for your time.
Thank you.
No, it's been really wonderful. Thank you very much, Brian. And please keep writing those books and making your TV shows and everything that you do to help us out. And just a real treat. Thank you very much.
It was a real treat.
Thank you very much. Enjoyed it.
Thank you, sir. See ya.
Bye.
Bye.
Well, that was the always fascinating Professor Briane Greene.
He knows stuff. He knows stuff all about the universe and the ins and outs and the big stuff and the small stuff.
Felt like we barely scratched the surface, but I wonder if maybe with someone like that, you always feel that way because he's dealing with massive things.
And tiny things.
So everything.
Yeah. Smallest of small quarks, strings, to the biggest of big. What's the biggest thing?
The biggest thing ever.
Biggest thing in the universe.
Elephant's arse.
Correct.
Yeah. Thank you. Points for me. Well, amazing. Oh, I forgot. We had some gifts sent to us.
We have gifts.
Bye. And there's a lovely note here. Hang on, I'll read this out while you hold up some wonderful things. Hello, boys, says Steph. Here are some gifts to help decorate the new studio. Now, we're not in the new studio yet.
We will be.
Well, will we, do? You like the cross stitch so much that I stitched another one so you could have one each. Steph, that's very sweet. I want to learn how to cross stitch.
She says.
No, this is me talking.
All right, because I was going to say she knows how to.
Maybe I'll learn it. Maybe that'll be my next skill. She also says, big thanks to everyone involved. Brackets, not John, because he keeps messing stuff up. She didn't say that bit. The podcast is absolutely lovely, says Steph, and her Instagram handle is Click and Tuna. That's K-L-I-K and Tuna, or as the Americans say, Tuna.
Click and tuna.
Click and tuna, buddy.
You like them fish?
Anyway, she sent us a lovely cross stitch of Merry and Pippin levitating an onion, it seems.
Levitating an onion using nothing but the power of the pipes.
And then 2 wonderful framed pictures.
One of me and Dom in human form and one of me and Dom in hobbit form.
And what are we saying around the outside of that image?
I'll watch your back if you watch mine.
Which was the thing that I wrote to you in a card on the first day of filming, which I'd forgotten all about.
You have no memory of it to this day. Do you still not remember?
No, not at all. It doesn't ring a bell at all. And then this other one, which is fantastic, that's Merry and Pippin, maybe on Weathertop, enjoying a wonderful raw onion.
Well, there wouldn't be time on Weathertop.
No, maybe in the Shire after a long day's gardening.
Perfect.
Enjoying a wonderful raw onion. So thank you,
really
Steph.
Lovely. Thank you.
If there's anything you guys want to send in to us, I'm sure you can. There'll be an address somewhere.
There's probably an address, but if not, you can always email us and somebody will send you the address. You can email us at thefriendshiponion@castmedia.com.
Or you can send us a voice note at speakpipe.com/thefriendshiponion. We're also on YouTube. If you guys are watching, you know all about that. And there's a Spotify playlist that includes all of our funky songs, which is The Friendship Onion. Be mindful, there are some people pretending to be us on Spotify, so you need to look for the official one.
Look for the official one. And if you do review the show, don't forget to take a screenshot and tag us in it. We'll stick it up on our Instagrams or we'll read them out here on The Friendship Onion.
Friends, we'll see you next week.
I'm off to read some Briane Greene.
See ya.
Bye.
Toodles.